Our topic for today is the difference of two odd powers. Last time we have the difference of two cubes. We have here quantity A minus B times quantity A squared plus AB plus B squared equals A cube minus B cube. So A cube, the power is 3, which is an odd number, and B cube is also a power of an odd number 3. So this is the difference of two cubes. Now we are going to discuss the difference of two odd powers. The difference of two odd powers follows the same pattern with these two cubes. We have here A squared, the square of the first term of the binomial A minus B, which is less than 1 than A cube, less than 1 power. So 3 minus 1, 3 minus 2 is 1. So first term of the trinomial, we have here three terms. First term of the trinomial is 1 less than the power of the answer. So this is the term. The middle term is the product of the first and the second term of the binomial. We have here minus, plus, plus. The last term is square of the last term of the binomial. So for the difference of two odd numbers, we have here quantity A minus B times quantity A to the fourth plus A cube plus A cube B plus E squared B squared plus A B cube plus B to the fourth. So I have here the first the binomial is A minus B, the same as the multiplier for the difference of two cubes, A minus B, and we have here all are plus, and this polynomial plus 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 plus. Then the power of A is 4, and it's descending in the polynomial 4, 3, 2, this is 1, and the power of B is ascending here 1, here 2, 3, and the last is 4. So by distributing A, multiplying A to each term of these polynomials, we have A times A to the fourth is A to the fifth. A times A cube B is plus A to the fourth B. A times A squared B squared is A cube B squared. A times AB cube is A squared B cube, and the last is A times B to the fourth is AB to the fourth. So let's distribute also, multiply also minus B to each term of the polynomial. So a minus b times a to the fourth is minus a to the fourth b. B times a cube b is a minus a cube b squared, and minus a minus b times a squared b squared is a squared minus a squared b cube, and b minus b times a b cube is minus a b to the fourth, and the last minus b times plus b to the fourth is minus or negative b to the fifth. So here we have opposite sign, and they are like terms. They're like a minus a b a to the fourth b, a to the fourth b, but opposite in sign. So this is, by combining like terms, this is 0, and also this one, all are a cube b cube, but opposite in sign, 0. A squared b cube, opposite in sign, so this is 0. And also with this one, this is 0, so 0. So all of these terms are 0, 0. So what is the two terms that are going to be left is this one. So the final answer is a the fifth minus b to the fifth. So this is an odd power, 5 and 5. So multiplying a minus b, quantity a minus b times a to the fourth plus a cube b plus a squared b squared plus a b cube plus b to the fourth is equals to a to the fifth minus b to the fifth. So the long process of multiplication is now just shortcut by the two terms, two odd powers, 5 and 5, all are in exponent 5, which is an odd number. So just remember that you have here a minus b is being multiplied to a to the fourth, an even number, and the exponent of a is descending. You have here to the fourth, you have here cube, you have here squared, this is power 1, and b here is ascending. You have here power 1 here, you have 2, you have cube, square, cube, and to the fourth. So the final answer is a, you just add, you just cube, you just the e here must be in the 5, e to the fifth, and minus b to the fifth. You can shortcut this one or do multiplying a to the a times a to the fourth, and b minus b multiplied to b to the fifth, b to the fourth. So b a to the fifth minus b to the fifth. Example, you have here x, quantity x minus 2 times ax times quantity x to the fourth plus 2x cube plus 4x squared plus 8x plus 16. If you are going to you can trace this one, you can trace this polynomial back to x and 2. So we have here it's the same as or equal to x quantity x minus 2 times x to the fourth and 2x cube plus 2x cube, and here we have 4 and 2 squared. 2 squared is 4 x squared plus 2 cube, which is equals to 8, plus 2 to the fourth, which is equals to 16. So back to here, so we can shortcut the process. We just multiply this one and this one, and minus x to the x multiplied to x to the fourth minus 2 times 16, and x times x to the fourth is x to the fifth, and this is 16 times 2 is 32, and the sign between here, the sign between the two is negative or minus. So you have here the final answer is a to the x to the fifth minus 32, because 2 times 16 is 32, or 2 to the fifth is 32, and x to the fifth is x times x to the fourth is x to the fifth. So the final answer is x to the fifth minus 32. So for this one, we have here the next odd number to 3 is 5, and the next odd number is 7. So in order to have a power of 7, you have here you should have a quantity a minus b times a to the 6 plus a to the fifth b plus a to the fourth b squared plus a cube b cube plus a squared b to the fourth plus ab cube or ab to the fifth plus b to the sixth. So we have here the descending power of a, power to the 6 to the 5th to the 4th cube square and 1 here, and for b it's ascending power b squared b cube 3 b to the 4th b to the 5th, and the last is b to the 6th. So answer is here for this one is you just multiply this one and this one, so a times a to the 6 is a to the 7, and minus b times b to the 6 is b to the 7 power. So we have here the final answer is a to the power or exponent 7 minus b to the power 7, or b the power of 7 or exponent 7. So you just raise this one to the power of 7 and this one to the power of 7 also. You just raise a to the power of 7 and b raised to the power of 7 also with the sign minus between them, or multiplying a times a to the 6, and this one minus b times b to the 6 is b to the 7, and a times a to the 6 is a to the 7 minus b times b to the power of 6 is b to the power of 7. Just remember the descending power of a, while b has the ascending power. And we have here, this is to the 6, so the answer must be a to the power of 7. This is also to the power 6 minus b to the power of 7. That is how we solve for the difference of two odd powers, starting from cube to the power of 5 to the power of 7, and you can expand this to the power of 9 if you wish, but it's a long set of polynomials. There are so many terms for the polynomial, but it is possible to solve.